Welcome back, my friends. Look at my snake head catching its own food on its own. Do you realize that it's running in the auto mode, going from food to food, in fact, going to the nearest next food and picking it up, going to the next one, picking it up, and then eventually it'll come back to zero, like zero, zero, the center, and tell me how efficient it has been. In fact, when I played the same arena, I had taken 3000 steps, but notice my auto mode, which is the snake finding its own food like a robot, does this in almost the same steps as the optimal. In fact, it does it slightly better than optimal, and there is a good reason for that. Hello, my friends. We are enhancing the Hungry Traveling Snake project from the YBite Python curriculum available at www.ybyte.in. In this video, we will see this extremely interesting feature of making the snake run in an automatic mode as I just showed you. So like I said, the auto mode is when snake finds the food by itself and picks up the food items. We just saw this. When does the auto mode kick in? Well, in our project, we'll first play the regular game because that way we can compare, how well, let's say, the auto mode performs compared to how well we performed. At the end of this, we'll clear up the screen. We'll place the food turtles once again because we have the food position list. And we, at the click of enter, we'll enter the so-called auto mode where the snake will do the job by itself. Now, in order to not confuse with the regular mode, we will use new turtles. For example, for the snake head, I'll use a turtle called T auto. And also for the segments, we'll use segments auto. Now, this is important because remember the turtle T, it's still binding with the keys. So if I were to somehow, use the same turtle, it can get a bit, the keys can still interfere. But with the new turtle, it's totally on its own. And that's the whole idea. Now we do this in two steps. First, we set up the basic playing loop, which is exactly same as what was going on in the so-called manual mode, which means that we figure out things like, if determine if the food has been eaten, making sure that the eaten food follows the snakehead as part of the tail, making the game to be over after the snakehead gets back to zero zero and having eaten all the foods. Now, on completion, we can also report the steps. So first, let's just do this much. In fact, I have already done this much in the code. I'll show you first how that code looks like, and then we'll move on to the more interesting, let's say the auto mode stuff. So notice in my project, the main game loop, which is the game loop that we have been developing, gets over at line 379. After this, I have removed the indentation. Now, this is where it gets interesting because remember, indentation is everything. Indentation controls a while loop that controls the game. If I break that indentation, I have broken out of the loop. So that's part is important. Be careful about this. Otherwise, the whole game will get messed up. Now, I put an input statement because I want the user to click enter to get into the auto mode. Once the user does that, like I said, I clear up the screen. So I remove the reports, I remove the pen. I go and place the food once again. And I can do this because list of foods contains all the food. Food pause contains all the locations of those food. These two lists are available to me. Using this, I can place the foods. I make them purple color. I create a new turtle called T auto. I record its position. And once again, I set up a similar loop like the previous game loop. So here I just say while not done. Remember this part is the code where I'm detecting if food has been eaten. So if I get too close to a food, let's say less than 20, I say that food has been eaten and I append that to say this list called segments auto. The only difference here is I'm using a variable kk to keep track of how many foods have been eaten. I increment kk because it means that the food has been eaten and I must now go to the next food. Next, I have this code where turtles move in the tail. This part is exactly same as earlier. We've looked at this in detail in the past. So I just kind of copied it here. Notice, however, that variable I have changed to JJ because remember, as I told you, KK is being used to track how many foods have been eaten. So just that there's no conflict, I have made all these variables into JJ. Finally, I have this piece of code where, if my snake gets, let's say snakehead has eaten all the foods, it must come back to zero, zero. And once it does get to zero, zero, it, in fact, or let's say close to zero, zero, it writes this reports for me. In my case, I'm telling the steps that I took when I played the game manually, the steps that the auto mode took, and the steps that basically would be the optimal distance. So this lets me compare and gives me a good feel of how efficient or how inefficient we have been. Finally, we have the same, as the main game. T auto forward and T say time dot skip. So it's basically the exact same thing. Now it's time for us to build it further. In fact, that's where I'm going to write the code and get into the auto mode. Now in the auto mode, the snake must move on its own. which means that the code must determine the snake's heading, must figure out which direction the snake should go. This is unlike the manual mode where the player was setting the direction using the arrow keys. But apart from this, the entire game loop works exactly the same as we just saw. In fact, this is very, very, very interesting. A little bit like line follower robots. Look at this. If for those of you interested in robotics, this code is actually quite interesting. Now, really, there are a few key decisions to be made. First and foremost, we must figure out where the snakehead must go next. Now, remember, the snakehead must eat all the foods, and after having eaten all the foods, it must come back to 0, 0, which means that snakehead is either going to go to a next food, which is available from this list, let's say NN order, NN is the nearest neighbor order, but of course, we can make any order. Or we are going back to 0, 0 in case snake has eaten all the foods. But in either case, we have the XY target location where the snake must go. And this is important because this keeps the game going. Next, we must determine the heading, the direction in which the snake must go. Now, this depends on where the target XY is. We will follow a policy that we will first go in the horizontal direction and then go in the vertical direction, which means that we will first make the X values, the present X value equal to the target X. It can't be equal, but let's say close enough. And then we'll make it go in the Y direction so that the Y value also becomes equal. We'll see this more closely later. And finally, we have to decide when to move to the next target, when to stop, etc. But as I told you, this part is already taken care of because once we eat new food, we just go to the, let's say, the next food and so on. And that's why I incremented the variable kk in the loop. We also know when to stop because once having eaten all the foods, snake comes back to 0, 0. That's the time to stop, and that is also already built in. So really, it's coming down to these two main questions. If we do this, we are in fact done. So let's look at this. First thing first, now deciding where to go next. Well, in fact, as we know, there are 10 foods. KK variable is keeping track of how many foods have been eaten. While KK is less than equal to 9, which means less than 10 foods have been eaten, all I need to know is which is the food that is on the order list KK, at the KK position of order list, and I just go to that position. Now think through this carefully. Let's say KK is 0, so which means that I have to go to the first food. I've not eaten anything yet. I will look at the top of this list order and say, okay, look, let me go there. Once KK is 1, I look at order 1 because that's the second food that I have to eat. Now this order list could be nearest neighbor, like I said, or it could be some other order that you want. But either case, always going to a food. Once we have finished, let's say, all the foods, which means KK is 10, I know that next position is 0, 0. And from this, I can extract next X and next Y. Now, next pause here is a tuple, but we can look at next X and next Y because that helps me to sort of, figure out where I have to go. So having decided the target that I have to go, I will now decide the heading. So I say, okay, let me look at the present X and the present Y. Now, like I told you, the policy I am following is that I first move horizontally and then I move vertically. Of course, this can be done differently, but that's the policy I've chosen. So first I compare the present X to the target X. And if I find that, these are still quite far away, it's still time for me to move horizontally. So here I'm doing, well, look, if the absolute value of present X and next X are different by 10, we'll talk about this 10 in just a moment. But let's say it's, there's still some gap to go before I reach the target X. Then I must move horizontally. And which direction do I go? Well, if my next X is more than the present X, which means that my X, my target is still to the right of wherever I am, then I'll continue to move in heading of 0. 0, remember, means right, else I'll go left. Now, once I have completed the X, which means I've aligned with the X of the target, time for me to move the Y. In fact, I will use a similar logic. I'll just ask myself a question. Have I reached Y yet? If I'm still far from Y, then again, if my target is, let's say, higher than wherever I am, then I go upwards, else I go downwards. Now, this code in the present form, the way I'm showing you, it may look very simple, but I urge you to be very careful about this. Think about this because any mistakes in this can cause infinite loops. For example, one mistake that I was running into is that previously I had said, okay, because my steps are 20, so I had put this threshold also as 20. So I said basically if apps present x minus next x is more than 20, then do all this. But then there was this corner case that sometimes my snake would get stuck near the food but just keep going up and down. And then I realized that the problem was coming because the present x and next x difference was exactly 20. In which case I thought, okay, I'm done with x, I'm going to y, but then I'm actually not done with x. So for that purpose, I've said, okay, look, steps are 20 pixels. I'm taking 10 as a threshold, and that seems to work better. In short, my message is do this carefully, go through this slowly, because any mistake in this code, you will find turtle will do funny things. It may get stuck in an infinite loop. It may eat a few foods and after that just kind of run away and so on. Also, if you have any other ideas on how this algorithm can be made better, or you have some other way of approaching this, most welcome to leave a comment. I'll be very happy to discuss with you. But let's get on with this. Let's develop this in our code. So I come to my code here. Remember, first thing I'm going to figure out, okay, where to go next. Say where to go, let's say next. And that, like I said, and like I said, is, well, I say if kk is less than equal to 9, um, I just say, well, next pos is, food pos. Basically, I just have to go to another food. For me, the list is called n order. So I just say n order kk. On the other hand, if this is not the case, well, time for me to come back. So I just say next pos is, say, 0, 0, because that's very much come back. Now I from this extract, let's say next x equals to, say, next pos 0, and say next y is equal to, say, next pos, say, 1, because first position is x, second position is y, and that's all. Yeah. Now, having done this, I will figure out where I am right now. So for that, I have this next x and xy to sort of mean target x and target y. Where I want to go is where I am right now is actually, say, what I'll just call it present, let's say x. And this will be the present position of the turtle. So t dot auto dot, say, x score. The present y would be present, let's say, y. That's t, say, t underscore auto dot, say, y core. So I know where my turtle is right now. Like I said, I now make a judgment. If the absolute value of present, let's say, x minus, let's say, next x is, say, greater than 10. So basically I'm saying that, look, you still have some way to go, still move horizontal, move horizontal. So you still have some way to go before you reach the X target. So I just now decide whether I go right or left. So I ask myself, okay, if next X is greater than, say, present, X, well, in that case, I must keep going right. So I just say t underscore auto dot, say, set heading to, say, 0, because I just want to keep going right. On the other hand, if that is not the case, I will just say t underscore auto dot set heading, uh, you know, 180, because then the turtle must come left. Now, once this condition has been, let's say, completed, so I come to a position where absolute value of present x and next x is less than 10, which means I'm not no longer entering into this. It means that I have finished my x, I've kind of reached close to my x. So I just say, well, else condition. So let's just say x done. Now say y. And in fact, I'll make the same judgment for y. So I ask myself, okay, if my y is still far away, so let's say still more than 10 away in absolute value, I figure out, is it higher than me right now or is it lower than me? If it's higher, which means next y is more than the present y, I will move in 90 degrees. Else I move, for example, in 270 degrees. Now, a very, very, very important point to understand and kind of visualize is that this entire if else condition is running as always inside a while loop, which means that every time I move 20 steps, I make the same judgment once again. So I look at the present position, I say, okay, next position still further, I must still either move right, left, straight, or say up or down. Now this runs in the while loop. So really what we are doing is that instead of the arrows deciding where I go, it's this algorithm that is deciding. Like I said, be careful with this, because this looks simple, but any mistake this can cause the turtle to go here. So let's see this in action. I have got my snake ready. I am eating my foods here. Let's see. So I have to be careful. Get to, let's say, the next food. It has to be this, because remember, I'm being helped with this nearest neighbor. So I can be quite efficient. I think I'm doing quite okay so far. Let's see. So I go and eat this. I go and eat this. And finally, I will go and eat my last food and get to, let's say, 0, 0. In fact, I think I've been quite close to optimal. Let's see how good or how bad I've been. It tells me, yeah, not bad. In the optimal steps of 2000, and I did in 2300 steps. I could see that clearly. Now let's see the same thing in the auto mode. So I click enter. Again, the food gets, spread out in the feed. Notice my snake is doing this X first and then Y, and looks pretty cool. It goes to every food, X first and then Y. It's going obviously a little bit more efficient than I am, but pretty cool anyway. So just goes, it's going to pick up the last food, goes to the X value first very clearly, eats this, and then it comes back to 0 0. And I notice that my snake has done this, in fact, in slightly lesser number of steps. Obviously, snake auto mode was more optimal than whatever I did. Uh, in fact, I had done this many times before, and I found that every time the auto mode turned out to be a little bit less than the optimal, which got me thinking, how is it even possible? Because even the optimal modes have been computed using nearest neighbor, and the snake is also going using nearest neighbor. So how is it that the auto mode is outperforming the so-called optimal mode? But then the reason really is that the optimal distances have been computed using the exact XY locations of the turtles. But when you play the game, you realize that you don't actually go to the exact locations. The moment you come somewhat near a food, let's say within a distance of 20, we declare the food has been eaten. And that's why, in fact, steps taken in the auto mode can actually be a little bit less. I hope you found this interesting. I really think this enhancement is quite phenomenal. In general, if you think this way of learning by building activities, enhancing them, thinking through them is something that you enjoy, look at our website www.ybyte.in, because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.